This is what I mentioned in the previous session, this whole notion of cross-cutting. So you've got some requirements that don't impact any lines of code at all. You've got some requirements that impact only a few components, and you've got some requirements that impact an enormous number of components. There are various kinds of crosscuts. They're universal crosscuts. So if you've got coding standards, right, it's theoretically going to impact every line of code, which could be in the millions. If you've got homogeneous crosscuts, and all of this is terminology I made up, folks, so you're not going to find it anywhere else. That means you're doing the same thing anytime that you need this to achieve whatever it is you're trying to achieve, like logging. You're going to do the same thing at every site in your code, right? So if you log on the entry to a component, or you log on the exit to a component, or both, then you're going to have the same code. Now, the hard stuff is heterogeneous stuff. So in safety, I've got a whole lot of safety hazards. I've got a whole lot of mitigations, and those mitigations in general do not look like each other, right? And so I'm going to have to find out where in the code I need to stick the mitigation, and maybe it's multiple places, and then what am I going to do exactly at that site to mitigate that problem, which may be different at a different site for the same problem. Heterogeneous stuff is really, really hard and critically important. You get it wrong, you're not mitigating what you need to mitigate, and bad things are going to happen if something goes awry at that site. So, what am I saying? I'm saying that, let's say we had a development process that looked suspiciously like Agile, right? And so we're going to write our first component to do whatever the functionality in this iteration is about. Well, that's great. That's on the left side of this. But we've also, if we have figured out the things that matter, the cross-cutting things, that matter, then there's a bunch of other stuff that have to go in that same component that have nothing to do with its kind of inherent reason to exist. It's existing to support or provide a certain functionality. Yeah, that's good. We need that. We also need these other things to go. So you could actually imagine writing a whole set of components with with only modest understanding of the functionality that they support, because that would give you a clue as to which of the quality attributes were important, what the hazards relative to those quality attributes are, what the mitigations relative to those quality attributes are, where they should go, and so you can write a whole lot of code over here that has absolutely nothing to do with the basic functionality. Anybody, does that make sense to anyone? Do you actually find that there's code in the component that has absolutely nothing to do with the basic functionality that the component is doing?
That's a common complaint of our developers. Like over half their code is just exception try-catch blocks.
Right.
So.
Right. It's handling stuff. Handling stuff. Yeah, over half. That's a common complaint. That has been a common complaint forever.
But they have no policies around it, because it's like they have try-catch blocks around a function that is entirely inside a try-catch block. So it's like completely no-throw, and they just put a try-catch block around anything.
I see.
When in doubt, try-catch.
Yeah, it's good if you understand what you're doing, rather than just mindlessly following rules, which may not have.
Well, they don't have rules either. It's just,
excuse me?
They don't have rules either. It's just kind of.
I see. No rules.
Tribal knowledge.
You're not doing safety critical stuff, are you?
We used to work for Boeing.
Oh.
No, just kidding.
I've heard of them. I've heard of them. Yes, okay. So the point is that I'd like you to get this diagram in your head and say to yourself and to others you work with, this is the norm. This is what we should expect. Because we got these cross-cutting guys that show up in a lot of different places that have nothing to do inherently with the basic functionality being provided by the component, but they just need to be there because we got all these other requirements that we don't think about very much. So to minimize quality debt, I mean, you've all heard of technical debt, right? So we get technical debt, we do stuff, we don't do stuff. Well, some of that technical debt is quality debt, right? That we either we are missing things that should be there. That makes us much quicker, of course. If we just ignore the right side of the figure and only create modules to do the left side of the figure, we very quickly get software that, quote, does what the customer wants. Okay? Now, the customer didn't say, oh, by the way, you shouldn't kill me, or you shouldn't drain my bank account, or you shouldn't allow, thieves in there to take my credit card information. That's generally not where their mind is, right? And that's perfectly appropriate. But it needs to be, if you remember, the different types of requirements and who's responsible, the developers are responsible for that stuff. And communicating to our friends, the customers, by saying, yeah, we're going to supply everything you want and a bunch of stuff you need, but you may not be aware of the need until bad things happen. Cross-cutting requirements should be identified early. Remember I talked bathwater, big requirements up front, bad idea, throw it out. But quality requirements up front is important. Remember that for each quality attribute requirement, you must design strategies to achieve it, to verify it, and to monitor it. Quality design up front, or QDUF, means doing this strategy design early so you can implement these strategies in each component as components are created. This way, QDUF minimizes quality debt by identifying cross-cutting requirements early, along with early design of their associated achievement, verification, and monitoring strategies. Delaying this strategy design might result in some quality requirements becoming uneconomical to implement. I believe the most efficient way to perform these quality development tasks is to use the information in your copy of the LightRM quality model and then embed the resulting specifications and strategies in your model. This incrementally increases the usefulness of your model. We already understand that one quality attribute may depend on another. The LightRM quality model says that all external and mixed qualities depend on all internal qualities. In addition, some mixed qualities, such as safety, depend on many other mixed and external qualities. A quality attribute with a deep dependency stack, such as safety, is fragile. It is both difficult to achieve and to preserve. If a quality's dependency stack is not clearly understood, the likelihood of achievement is small and preservation is unlikely. Software quality is a complex concept. It's difficult to achieve without a clear definition and measures for its various aspects. The LightRM quality model suggests that software quality has at least 4 of these aspects: behavior, misbehavior, user interface structure, and internal design and code structure. User satisfaction with the software's behavior entails both functionality and external qualities such as responsiveness. If different user groups value different software behaviors, this would result in a weighted average of user group satisfactions. Another aspect is acquirer satisfaction with the rarity and mildness of the software's misbehavior, where acquirers are those parties who will be sued or go out of business because of disastrous failures. This reminds me of a nursery rhyme about the little girl who had a little curl right in the middle of her forehead, and when she was good, she was very, very good, but when she was bad, she was horrid. I think this applies to software also. A third aspect is satisfaction with the software's user interface. As with the behavioral aspect, this may result in a weighted average of user group opinions. The fourth aspect is developer, tester, and quality support satisfaction with the software's internal qualities, as defined by the LightRM quality model. According to this view, high software quality implies high user satisfaction with software behavior, extremely rare disastrous failures, highly usable interfaces, and high developer, tester, and quality support satisfaction with internal qualities such as understandability. Most software professionals have a shallow understanding of quality attributes and their associated requirements. Therefore, some form of help is needed to support the development of quality software. One form of help is a quality support group that focuses on these issues and helps their peers succeed. Another form of help is to expand the responsibilities of your software architects to include quality support. You may be tempted to expand the responsibilities of your quality assurance staff. While this might be effective in some organizations, in others, quality assurance groups focus on testing. While they provide valuable service, such QA groups have no deeper understanding of quality attributes than the developers they help. No matter how quality support is implemented, one tactic they could use is lunch and a video. The idea is to gather a development team and show them one of the videos in this series, followed by 10 minutes or more of open discussion. Analysis of the full LightRM quality model prompted the insights covered in this video. Simplistic requirements models prompt few insights. The content of this video shows the power of essentially complex models.